AWS NoSQL DynamoDB. Hey everybody, this is Ben Finkel, and in this nugget, we're going to take a look at Amazon's NoSQL database as a service called DynamoDB. We'll spend a little bit of time talking about the differences between a NoSQL database and an SQL database, what makes these two structures different. Then we'll talk about how DynamoDB specifically is architected, what the different items or the different pieces of a DynamoDB are, and we'll finish up by briefly talking about when you should choose RDS versus when you should choose DynamoDB. You can store data a lot of different ways inside of Amazon Web Services, and during my nugget on Relational Database Service, RDS, I talked about some of the things that you need to consider when you're looking at your data, things like your format and your size and your query and writing frequency, your access speed. And I sort of broke it down into two different types of databases that you might think about: unstructured or blob data storage and relational data storage. And then we went and talked about Amazon RDS, which is a sort of traditional SQL-based relational data model. Well, there's another option these days that is gaining in popularity the past few years, and that's called NoSQL databases. And NoSQL databases, like the name sort of implies, are databases that don't use traditional SQL relationships in order to model their data. You may have heard of some databases such as Mongo, Cassandra, and Redis. These are really popular NoSQL databases that are out there right now. Well, Amazon has its own built-in NoSQL database as a service inside of the cloud called Amazon DynamoDB. And we'll talk about this a little bit later in the nugget, but trying to understand the difference between SQL and NoSQL databases is going to break down on a few different points. First of all, whereas SQL databases typically use rows and columns to store their data, NoSQL databases like to use key value pairs or property bags, often known as attributes, in order to store that data. SQL databases are famously very fixed in their schema. You can't change a table, you can't change the structure of a record, whereas NoSQL databases have a very flexible, very dynamic schema. So individual records inside of a table may very well have completely different schemas. You query SQL databases, of course, using SQL, structured query language, whereas NoSQL, you're going to focus on working on document querying. So you're going to query individual items and maybe even manipulate and work with them inside of code as opposed to inside of your SQL. And then scalability. SQL scales vertically. What that means is that when you need more power, more speed out of your SQL database, well, you put it on a bigger box. You give it more CPU, more RAM. You make it a more powerful machine. Whereas NoSQL databases scale very easily horizontally. When you need more speed and performance out of a NoSQL database, you just add more machines. You don't have to make those machines necessarily bigger. It scales out horizontally or widely very, very easily. If you're new to NoSQL databases, it can be a little bit difficult to get your head around. I know it was for me at first when I moved from traditional SQL databases into NoSQL. So in order to better understand it, I'm first going to talk about how DynamoDB is structured, and then from there we should be able to get a better sense of how and when we would use it. So the top level item or organizational unit for Amazon DynamoDB is a table. You're going to build and create tables inside of DynamoDB, and you don't build collections of tables in any kind of group for any kind of database like you might with a traditional database. Table is the top level. That's the largest, most highly organized item that you're going to run into. Inside of tables, tables are going to contain items, and you can think of items as being sort of similar to a record in a traditional database. If your table is employees, your items are going to be each individual employee. If your table is, I don't know, albums, your items are going to be each individual album that you're storing inside of that database. And then lastly, items contain attributes, and attributes are key value pairs like we talked about before. That's going to be your fields, right? So that's going to be underneath your employee. It's going to be the first name. That'll be one attribute. The last name, that'll be a second attribute. So it's very hierarchical, and it looks something like this. You can see here I've got my employee table defined up here, and I've kind of indicated two different items inside of this employee table. The first is employee ID 0913, and the second one is employee ID 1498. So each of these here is an attribute. Emp ID first and last, Emp ID name and age. And the very first thing that you ought to notice and that ought to stand out to you is that these two items are both inside of the employee table. They've got different attributes. The table employee is simply a collection of items. It doesn't define the attributes that these items have to have outside of what we're going to talk about in a moment, and that's the keys. But outside of the keys, These items can have completely different attributes if you want. There's no structure, there's no forced schema. That's when we talked about a dynamic schema. That's exactly what we're referring to. We may very well have a second table down here. I've indicated one called customer, and it would have its own collection of items. And each of those items, similar to above, would have their own collection of attributes. Now, a table can have as many items in it as you want. There is no limit to the number of items that can be in a table. And actually, tables can be as big as you want as well. There is no size limit on Amazon DynamoDB. That's one of the great things about using it, is you're only paying for the amount of space, the volume of space that you're taking up, and that scales up granularly with every individual attribute on every individual item inside of each of your tables. So you don't have to worry about provisioning space ahead of time. You don't have to worry about if you're going to run out of space or not. You effectively can expand to infinite amount of space. A very critical point about DynamoDB, though, is that little key icon there, those primary keys that I indicated on those items. Because tables are the top level organizational unit, there's a lot that you define at the table level, we'll say. Initially, every table is going to require a primary key. So your primary key is defined for your table, not on individual items, even though it applies to individual items. You have to define a primary key at the table level. So if you think about that employee table that I just talked about, and you've got an item in there, it's got 3 attributes on the first item, emp ID, first name and last name. Well, I indicated that employee ID, emp ID, is the primary key. That's called a partition key also in the world of DynamoDB. And what's important here is that now every item that I add to this table has to have emp ID. It's got to be the same name, EMPID, and it's got to be the same type. If I indicated that this was a numeric attribute type here, every item in this table is going to have a numeric type called emp ID. That's the primary key. And this is what Amazon DB uses in order to sort and index your records or your items. Now you can also specify a sort of secondary item. It's called a sort key, and this is completely optional, but if you specify a sort key, what you're indicating is that these two items together make up the primary or unique key of your item. So when you only have a partition key, a primary key, that has to be unique across every item. Once you include an optional sort key, now it's those two combined that create the uniqueness for your item. So you can have, well, I used an example of albums earlier. You might very well have the artist or the album name be your primary key, and then the track name be your sort key. And that way you can have multiple different track names inside of an item that is the same album name or the same artist name across multiple albums. Similar to the primary key, once you've identified an attribute as the sort key, that has to be available on every item as well. So an item cannot be in this table and be missing the sort key attribute. And then lastly, we have up to 5 what are called local secondary indexes. We'll talk about querying in a second, but when you want to query DynamoDB, if you want to query on anything other than the primary or the sort key, and you might very well want to query on another attribute besides one of those 2 keys, you have to specify an attribute as a local secondary index. So again, I'll reiterate, you cannot query against an attribute, say everyone whose last name is equal to Finkel, unless it's been specified as a local secondary index. And just like the 2 indexes above, once you specify an attribute as an LSI, well, it's got to be on every item inside of this table. So here is my second item that I've indicated in this table, and I've indicated that yes, it's got all of these 3, but then it's got an extra property here. I called it age, which does not exist anywhere on my first item, and that's okay because I don't have age specified as a primary key, a sort key, or an LSI, a local secondary index. Organizing and setting up your keys appropriately is a really critical part of setting up a good, efficient DynamoDB structure. You don't want to just make every property an LSI just for the heck of it. You want to make sure that you're only setting LSIs up on those properties that you definitely need to index. And if you've got a property that's really gigantic, really huge, you may think about separating that out into its own table so that you can make it a primary key instead of an LSI on an existing table. Another key piece of information that you set up at the table level is your throughput. You have to provision your throughput at the table level, and you're going to provision read capacity separate from write capacity. You use something called read capacity units and write capacity units, and they specify basically the same thing but in two different fashions. Read capacity units, every unit is equal to 1 strongly consistent read per second or 2 eventually consistent reads per second, whereas write capacity unit is 1 write per second. So if you provision a table with 10 write capacity units, you're going to get 10 writes per second. That is your throughput that you will be able to achieve on this table. And you can have a different table with a completely different write capacity unit throughput provisioned. This provisioned throughput is charged to you regardless of whether you use it all or not. You are effectively reserving this throughput, and that affects your pricing for your DynamoDB. So you, again, just like before with your indexes, you want to make sure that you set up your read and your write capacities appropriately so that you're not overpaying for what you need to use. Performing operations against Amazon DynamoDB is all done either through the management console, through the RESTful API, or through code through an SDK. So you're going to write Python code or JavaScript code. And basic operations are available: create, read, update, and delete. Queries are obviously the more complicated thing. Every database engine, you want to know, hey, how do I query my database? And in the case of DynamoDB, like we talked about, you perform your queries against the partition key and, if it's there, the sort key as well. So this is really important to understand when you set up a table and you identify a sort key. Obviously, every query has to include the partition key, and the partition key is required on the table. So you can only search by, well, in this case of my employees, I can only search by employee ID. If I've indicated the first name as a sort key, I also have to include that sort key in my query when I want to query these things. But however, you can optionally use your LSI, your local secondary index. And it's nice that it's optional, so you don't have to specify an LSI when you query, but you can, and a lot of times you'll want to. Just like all NoSQL databases, DynamoDB queries are going to perform based on the size of the result set, not the data set. So it doesn't matter how many items are in this table. There can be millions and millions of items. The performance of your query is going to depend on how many return from your query itself. So when it makes sense to use an LSI and reduce the size of your result set, you want to do that. That's a smart thing to do. Now there is another way to query the tables. It's not a very useful or highly recommended way, but you can perform what's called a simple table scan. And just like it sounds like, yeah, that's just going to scan through every item inside of the table one by one. You'll write your code, your SDK code or whatever it is going to be to scan the table, and all of those items will get returned back to you so you can walk through them. Obviously, if your table is very, very large, this could be very, very non-performant. This could be a very slow thing to do. So you want to make sure that you really only use table scans when they're appropriate. So hopefully at this point you understand a little bit about how DynamoDB is structured and how it works. The big question that everyone who comes to a NoSQL database the first time always has is, when do I use NoSQL versus when do I use a traditional relational database, a traditional SQL database? And you know, the answer is always going to depend on what your particular use case is. Most smart implementations, frankly, are going to use both. They're going to have a mixture of both of these different data models. So this is a little chart that Amazon put together that can help you understand when you use one versus the other. First of all, Amazon RDS is often great for existing database applications. It's probably already running on MySQL or SQL Server or Oracle DB. Well, in that case, it's easy to migrate it up into the cloud and use an Amazon RDS instance, whereas migrating to a NoSQL database would require a lot of rewriting of your entire database in your code. But NoSQL is great for new applications. So when you're starting up a new web-based application, think about Amazon DynamoDB. It's great for a large number of small, quick, fast writes and reads, whereas business process is more ideal for Amazon RDS. Amazon RDS is great for really highly relational, complex transactional data. Think about financial systems for a bank or an insurance agency, whereas NoSQL is good for the simpler data models that don't have a lot of relationships, don't have a lot of foreign keys, don't have a lot of structure to the data. Amazon DynamoDB scales a lot faster and a lot easier. It's on-demand scaling, basically based on your application requirements, whereas you have to architect and work with the DBA to cluster and partition Amazon RDS databases to scale those appropriately. So hopefully that gives you a little bit of an idea about when you would choose RDS versus DynamoDB. Well, that concludes this nugget on AWS NoSQL DynamoDB. Just to recap, we talked about NoSQL versus SQL databases, the structural differences between a relational table-based RDS database and a NoSQL database, which is sort of a document or attribute bag collection of key value pairs. Then we looked at the architecture of DynamoDB, how it's broken down into tables, items, and attributes. And we talked briefly about why you would choose RDS or DynamoDB in different circumstances. I hope this has been informative for you, and I'd like to thank you for viewing.